the electrical energy which should be converting into a here a heat energy, okay, and also which can store in a magnetic or a electric field, which is called a passive element. Active element means there must be a battery. Passive element means and battery sending the energy which is to be received by these components. Then you have to say that those are nothing but a passive elements. Next, what is a network? What do you call network? Here, network means a circuit which consists of a number of sources. What do you say? In previous in circuit which consists of number of sources of electromotive force. So there may be a one source. That source is nothing but a battery. Okay, E1, and also another battery is there, E2. So like that, here there must be a number of sources which is to be generating the electromotive force, resistors or other elements. So what do you say? Those are other elements means inductor L, capacitor C, like that. And also which are to be connected in a complicated matter. All these inductor, capacitor, resistor, which are battery, all are to be connected in a complicated matter. Then you have to say that this is nothing but a network. And also when a network which contains only passive circuit, what is passive? Only energy, only battery is there, and no source of EMF, electromotive is there. Then you have to say that that is a passive network. Okay, and the network containing sources of EMF and also the other circuit element which is called here active network. So if the resistance or the impedance R or Z or of a passive circuit element does not depends upon the here current or voltage. That means what is the relation between the current and voltage, which can also gives the a constant ratio. That means I by R or R by I, whatever it may be. Then the element you can call it as a linear element. And a network with linear circuit element which is called a linear network. Next, what is mesh? Mesh you can call it as a loop here. One minute. So here, what is a mesh here? A mesh or a loop. Okay. So you can call it as a mesh or a loop here. So which when the different branches from a closed path, different branches from a closed path, that means different branches means here, whether it is a RC combination is there, LC combination is there, battery E is there. So when the different branches from a closed path in the network, you can call it as a mesh or a loop. And what is nodes are? Another one is also there. Mesh you can call it as a loop, and another node, node is you can call it as a junction. So what is a junction? A terminal point common for two or more branches. You can call it as a node. Yeah, you can go for the mesh and network analysis. Here we are going to be discuss about the KCL, Kirchhoff current law, as well as the Kirchhoff voltage law. So what is the Kirchhoff current law? The algebraical sum of the current at any junction in network which is always zero, or the current meeting at a point which is equals to the current leaving from that point. Okay, that is called here Kirchhoff current law, KCL. So the algebraical summation over I equals to 0. So that this means that there is no accumulation of electric charge at any point in the network. Next, what is Kirchhoff voltage law? So here the KVL which is to be indicating that any closed circuit, the algebraical sum of the product of the current and resistance. Current and resistance means I and R. Algebraical sum means summation. So which is R impedance. Okay, resistance you can call it as a impedance Z for each mesh, which is equal to the total EMFs. EMF means electromotive force. Okay, Randy. So you can go for this, whether it is a the current law KCL leads to the method of network analysis. You can call it as a node analysis, and voltage leads to the other network. You can call it as a loop analysis. So this is the difference between the node analysis and loop analysis. Node analysis, current KCL implemented, and then here loop analysis, here voltage should be KVL law, which should be implemented. Yeah. Next one, superposition theorem. This may be asked as so many times. You can go for this. This is a short question to you. What is superposition theorem? Let us discuss about the statement of the superposition theorem. In any linear network, I just spoke about the what is a linear network, which contains the linear impedances and energy sources and the current in any element, which is the vector sum of the currents and that are separately caused in the element. If each source of EMF are considered separately, of course, of all other sources being replaced at that time by the internal impedances. So let us consider for this a diagram which contains the two EMF. What is that? E1 and E2 is there. So what is the internal impedances? Z1 and Z2 there. When voltage E is there, resistor Z or impedance Z is there. So that E and Z is there according to the Ohm's law, V equals to IR. So that V by I is nothing, V by R is nothing but I is to be produced here. So that for due to E1 and Z1, how much of the current is to be developed here? I1. Similarly, in the right hand section, there should be a EMF E2 is there. EMF is nothing but a potential, and Z2 impedance Z2 is there. E by Z2, E2 by Z2 can give the current I2. So the mesh 1 which is generating I1 current, in mesh 2 the current is generating I2. So the total current which is passing through the impedance Z3 is nothing but a I1 plus I2. Okay, Randy? You can go for this. Okay. Next. So here you can find out the what is the current through the impedance Z3. Okay, this can be obtained by using the superposition theorem. Let us imagine the three cases here. First of all is that EMF source E2 is removed. Where is E2? Right hand side E2 is there. If you are going to be removing the E2, but Z2 is going to be present there. Let us consider that I1 be the current in Z3 due to the E1. Okay. Similarly, next E1 is to be removed and Z1 is to be present. So in this case, I2 is to be passing through the Z3 due to the E2 yellow. So what is the total current which is passing through the Z3? The total is I1 plus I2 is the current which is passing through the Z3 when both EMF sources are operating. So you have to prove that by applying the Kirchhoff laws to these two first and second meshes here. E1 equals to Z1 plus Z3. What is E1 value? Z1 plus Z3 into I1 plus Z3 into I2. Similarly, E2 equals to Z3 into I1 plus Z2 plus Z3 into I2. So by solving these equations, you are to be getting the fourth and fifth equation. So this is the case here when E2 is removed. Here also you are to be calculating here what is the current which is passing through the Z3 value. And similarly, for next case, you can see the comparison between these two figures here. Here in for mesh 1, E1 and Z1 is present there. What is the Z3 current? IT. And similarly, here only E1 is removed. And if it is to be present E2 at the right hand side section, what is the current which is passing through the Z3? So that the summation over which is equals to the what is I1 dash value, what is I2 dash value. By doing this and simplification after the calculation part, I1 equals to I1 dash plus I1 double dash, I2 equals to I2 dash plus I2. So this can give the superposition theorem. Okay, Randy? You can go for it. Next, reciprocity theorem. Okay, 1 minute. What is reciprocity theorem? Here you can go for the statement for the reciprocity. In linear network, if source of EMF, electromotive, one mesh produce a current I in this second mesh. Once again, I'm going to be repeating this. If any linear network, if a source of EMF located in one mesh, that means how many meshes is to be considered here? Two meshes are there, first mesh and second mesh. So in this, if only one source is to be present in one mesh, so the current I is to be produced in the second mesh. Similarly, the same EMF which is acting in the second mesh, and here also the same current I which is to be produced in the first mesh. అంటే ఏమనుకోవాలి మనం ఇక్కడ? Can go for this. First mesh source is there, second mesh I is to be produced. If second mesh source is there, there is no source in the first mesh, so that I is also to be produced in the here. Which one? First mesh, like that, vice versa. Okay na? So you can see here the figure here, the source of EMF. మీరు ఫిగర్ చూస్తే అర్థమైపోతుంది. ఓకే, రెండు ఫిగర్స్ ని you can compare these two figures here. You can easily understand that what is going to be happening according to the statement of reciprocity theorem. You can go for this. Okay, so here also by implementing the Kirchhoff KCL and KVL and doing the calculation and simplifying this, you are getting this. Okay, so that I1 I2 dash equals to I2 equals to I1 dash, like that. Next, Thevenin's theorem. So this Thevenin's theorem, which is very important. This may be asked as a essay question to you. So what is the statement for it? Whenever these type of questions which is to be giving to you, one thing you should remember that here, first of all, you should write it down the what is the statement. Okay, later on you have to draw the circuit. In starting, I already told you that what is a network, what is a mesh, what is a loop. Okay, so that according to that, you have to draw. That means electric circuit contains source is there, here impedance is there, Z, and also current I is there. So I think so you can have an idea about this networks theorem. Each and every case, you have the source, impedance Z, current I is there. So you are going to be relating that if you choose two meshes, whether it is a first mesh or second mesh, according to that meshes, how much of the current is to be generating in the first mesh and how much of the current which is to be generating in the second mesh. When two sources are going to be here present, or else if only one source is present in one mesh, other mesh how much current generate? If other mesh which contains the source and previous mesh, how much of the current is to be generated, and is there any relations are there between these two currents? By adding the summation over these two currents here, how much of the value which is to be equating here, and by doing these calculations, whether the theorem is going to be fulfilling according to the statement here, you all these conditions have to check. Okay, so go for the Thevenin's theorem. What is the statement of the Thevenin? Any two terminals of a network. Okay, you can see here. Any two terminals of a network which containing source of impedance and linear impedances which can be replaced by an equivalent circuit and which is consisting of a voltage source. What is that? Thevenin voltage. What do you say? ETH? ETH is nothing but a Thevenin voltage. So which is in series with the impedance ZTH. You must so in this statement, you can have that here uh, there is a what is a open circuit and what is a closed circuit. So you have to differentiate with these. Okay. So in Thevenin's theorem, you can able to proceed that uh, according to that here. On yeah, reciprocity was over. Yeah, Thevenin. So the EMF of voltage source, which is equal to the potential difference between the two terminals in open circuit position. That means no external circuit which is to be connected. So here the series impedance which is equal to the impedance sources being replaced by the internal impedance. So according to that, you have to know about the what is the circuit diagram for it. So you can have it contains the here the figure A. How many figures are there? Three types of figures are. Sir, what is the difference between these three figures? So you can have see here. I'm going to explaining here. So where E is the battery here, E is the source is there. So what is the small r? Small r is indicating that internal resistance. Small r, what is small r? Small r is a internal resistance of this battery. So that here there is a impedance is there. What is that impedance value? Z1 value. When E is there, battery or the energy is the source is there, and impedance is there. E and Z is Z1 is there. So that what is E by Z1? According to the Ohm's law, మనం ఏ లా యూజ్ చేస్తున్నామండి? We are to be using the Ohm's law. V equals to IR, I equals to V by R. Similarly, E by Z1 is nothing but a I1 current. So in first mesh, you can able to observe that I1 current is to be generated. Okay. And also here output A and B are the 2-point sources. Okay, and there only we are going to be taking the what is the output value. There the load impedance is there, ZL. Okay, and in between there is a Z2 is also there. So due to the source E and the impedance Z2, E by Z2 is also going to be giving that how much of the here current is to be generated. That value is to be denoting here I2 current is to be generated or developed across the impedance Z2 through by the source E1. Okay, Nandi? And that what is the total impedance here across the load impedance ZL? What is the output value? Next, what about the figure B here? Battery is there, internal resistor small r is there, and impedance Z1 is there in first mesh. Second mesh, what is ETH? Okay, Thevenin voltage. Getting my point? ETH, writing in the form of ZL value, which is to be writing as a ETH. Okay, Z2 is also there across the A and B, output ETH. Next, you can see here, ETH should be replaced by ZTH. The same is there. You can see here, only internal resistor is there. There is no source at all. E is to be removed. Z1 impedance is there. Z2 is also impedance is there. R small r is to be considered here impedance. With respect to all the impedances, what is the total impedance? ZTH. ఓకేనండి, ఏ విధమైనటువంటి వోల్టేజ్ లేదు, ఏ విధమైనటువంటి సోర్స్ ని కన్సిడర్ చేయలేదు, ఓన్లీ ఇంపిడెన్స్ మాత్రమే కన్సిడర్ చేస్తే అవుట్పుట్ వాల్యూ ఏమవుతుంది? ZT. ఓకే, ఇక్కడ మాత్రం చూస్తే బెస్ట్ సోర్సెస్ మాత్రమే కన్సిడర్ చేయాలి, ETH గా రాసినాడు ఫిగర్ బి. ఓకే, సో దిస్ ఇస్ ద కంపారిజన్ బిట్వీన్ ది ఫిగర్ ఏ అండ్ ఫిగర్ బి అండ్ ఫిగర్. ఓకేనండి, సో Z1 and Z2 are the two impedance which are to be connected in series according to the first diagram, and A and B are the two terminals of the network. ZL is the load impedance or the external impedance. Okay, next figure B. What is figure B? With load terminals A and B, which is open. Open means no source is there, no energy is there. Okay, so in that case we have to calculate it that the open circuited electromotive force due to the voltage source. So that is value according to the figure B, ETH value. Okay, so for this purpose you have to calculate what is the current value. I equals to E by R. Okay, according to the Ohm's law. So I equals to capital E by what is R? Internal resistor small r is there. When you are connected in a series, impedances are connected in series, what is the total value? R equals to R1 plus R2 plus R3 and so on. That's why here you have been substituted the impedances value, total impedance value, R plus Z1 plus Z2. So if you want to calculate the what is the total source EMF value here, potential value, ETH equals to I into Z or I into R, current into impedance. You know the current value, E by small r plus Z1 plus Z2. And what is the impedance across the impedance Z2 value? So this is the first equation. And later on, if you are going to be removing the battery in mesh 1, and while the internal impedance is to be considered and corresponding point A and B, what are the Z1 and small r which is in series? What is the equivalent impedance of this? ZTH equals to R, Z equivalence equals to Z1 plus small r. So by if it is to be considering in a parallel circuit, what is the total impedance and the total resistance? 1 by R equals to 1 by R1 plus 1 by R2. If it is connected in parallel. Series lo aithe what is the total resistance? R equals to R1 plus R2 plus R3 and so on. So that's why here we are to be implementing these equations and these laws. You are to be calculating that what is the total impedance value. So that is equals to 1 by Z2 plus 1 by Z1 plus R. You have to substitute the what is the Z1 value and what is the Z2 value. By simplifying this, ZTH equals to equation. So there you have to substitute that You already got it, the ETH value, Thevenin Thevenin voltage or the Thevenin EMF value. So what is the ETH value? E by Z1, Z2 by R plus Z1 plus Z2. And what is the ZTH value? So now you have to calculate that. You know the E value, ETH value, you know the ZTH value. And across the two terminals A and B, what is the ZL value, load impedance value? Okay. So this is the equivalent, Thevenin equivalent. So, by applying the Kirchhoff current law and voltage law, and implementing and by substituting the current I value and doing the calculation part and simplifying, you can get the value, this value which is equivalent to that above equations. So these equation 1 and 2, whatever you are getting, those values are here same for this. So that the theorem which is to be proved. Hence the theorem is proved. Is Norton's theorem. Second most important essay question. First important essay question is Thevenin's theorem. Second one is the Norton's theorem. So let us discuss about that here. So here you can imagine that ఏం చేస్తున్నామంటే ఫస్ట్ ఇంపిడెన్స్లు ఏవైతే ఉన్నాయో రెడ్యూస్ చేసి ఒకే ఇంపిడెన్స్ కింద రాస్తాం. ఏదైతే సోర్స్ ని కన్సిడర్ చేసినామో ఆ సోర్సెస్ ని రెడ్యూస్ చేసి సింగిల్ సోర్స్ కింద రాస్తాం. Later on, if only one single source is there, if only one impedance is there, what is the total current which is generating power across the load impedance? That is to be calculated. So we have seen that Thevenin's theorem, which should be reduced to two terminals, active network of linear impedances and also source impedances, sources to the equivalent voltage. So what about the Norton's theorem? This can be replaces the network by an ఈక్వలెంట్ కాన్స్టెంట్ కరెంట్ సోర్స్. అక్కడ మనం వోల్టేజ్ గురించి మాట్లాడినాం, ఇంపిడెన్స్ల గురించి మాట్లాడినాం థెవెనిన్ లో. వెన్ యూ ఆర్ గోయింగ్ టు డిస్కస్ అబౌట్ ది నార్టన్స్ థీరం, వీ హ్యావ్ టు స్పోక్ అబౌట్ ది వాట్ ఈస్ ద కరెంట్ వాల్యూ. ఓకేనండి, let us discuss about the statement of this Norton's theorem. Any two terminals of linear network which containing the sources, linear network లో ఏముంటాయని చెప్పినా మనం ఆల్రెడీ స్టార్టింగ్ లో, which contains sources, impedances. Okay, sources means E value, impedances means Z value, which can be replaced. What you are going to be replacing? A constant current source in parallel with the single impedance. How you are going to be connecting this? Not in a series. You are to be connecting in a parallel with a single impedance. Therefore, the current is short circuited. The current between the two terminals of the network, while the impedance between the two terminals is the impedance when all sources of electromotive force which are replaced by their internal impedance. So let us draw for the Norton's theorem here. See here, you can see the diagram. Here, how many meshes are there? Two meshes are there. First mesh and second mesh. So here, the source is to be considered. The source is a capital E, and the internal resistor small r is there. Okay, for the source here, so that there should be a impedance Z1 is to be considered in the first mesh, and also Z2, which is to be parallel to that of the source and series with the here impedance here. Okay, now, and between the two terminals, what are those two terminals output? A and B. So across that, there is a load impedance is to be connected. So there also you have to calculate that what is the total current which is to be generating across the load impedance, which is to be considered at the 2 point sources, that is A and B. Okay, next, A and B when it is to be short circuit, See here, figure B, A and B, two terminals are short circuited. But here in the first case, these two are not short circuited. There is to be considered a load impedance. When it is to be short circuited, what do you say here? There is no, here current is to be passing through that. There is no to be impedance is to be present at that particular point. Okay. So what is the case here? Only if it is short circuited, only internal resistance, that is the impedance Z is to be considered, and current which is to be passed. So here for all the terminals capital A and B, which is to be short circuited in figure B. So when this short circuited, there is Z2 becomes ineffective. There is no here, no effective portion is to be considered here. So Z2 is not to be here in active position. So that the current flowing in the circuit, which is I equals to E by R plus Z1. Why here? Here Z2 is ineffective. So that's why here you have to consider only internal impedance small r and the Z1 which is present in the mesh 1. So E by R. E by R is nothing but a I value according to the Ohm's value. So this is to be denoting Norton current IN. What is IN? Suffix N is there. You can see here. Okay. IN. So this is called Norton current. Okay. When the ZL is short circuited. Next, AB terminals are opened here. Okay. So the battery is also to be removed. And there only you have to consider the internal impedance small r. That is for figure C. So that what is the ZN value? Total impedance. That is called Norton impedance. Zn equals to between the points A and B. Z plus R in Z1 plus R into Z2 divided by Z plus R plus Z2. So that why? Because of here these are in series. Total impedance to be calculated. So you have to do and you have to simplify this. So sorry. So in this case, what is the equivalent circuit of this first one? See here, మూడు సర్క్యూట్లు ఇచ్చినాడు కదా, మూడు సర్క్యూట్లు బిట్వీన్ ది ఏ అండ్ బి ఫస్ట్ పాయింట్ జెడ్ఎల్ అయితే, సెకండ్ లో షార్ట్ సర్క్యూట్ చేస్తే జెడ్2 పని చేయదు, బ్యాటరీ ఇదే. థర్డ్ దగ్గరకు వచ్చినప్పటికి మొత్తం సోర్స్ ని రిమూవ్ చేసినాడు. ఇఫ్ యూ రిమూవ్ ది సోర్స్, వాట్ ఇస్ జెడ్? Figure B, there only IN is to be generated. Figure C, there is a ZN is to be generated. Similar to that of the Thevenin theorem. That's it. If you know the Thevenin theorem, you can diagram and explanation for this Norton theorem also. So that's why here, what is the equivalent circuit? See here, equivalent circuit. Arrow mark indicate the source. Okay. What is the Norton current IN value across the Z2? E by R plus Z1. What is the Norton impedance Zn value between the points A and B across the load resistance ZL? Zn equals to Z1 plus R into Z2 by Z1 plus R plus Z. So this is the equivalent circuit for the Norton. Now you have to prove okay. So for this the circuit may be found. What is the equivalent circuit there? What? So this sends our here Norton theorem as well as the Thevenin's theorem, like that. And one more thing, we can go for that. Yeah, we have been successfully completed the current electricity in block 2. Electrical conductivity unit 5 is over, and Kirchhoff laws is also over. Just now we discussed the network theorem, page number 95. So Kirchhoff laws, mesh and node analysis, and the superposition theorem. Superposition theorem is also to be completed. Reciprocity just now. Thevenin is also over, and Norton theorem is also. Out of these four, definitely one Navier question is to be given to you. Okay. So what is the summary we have been discussed here? Uh, so many networks, which is electrical, here engineering and electronics can be analyzed, making use of the Thevenin's as well as the Norton theorem with the help of these two single networks. That is, which is become very easy to understand about the here working of each and every network. So you can remember that what are the model questions which is to be given. It's Norton's theorems here. Okay, so you have to explain about the what is the Thevenin theorem as well as the Norton theorem. State and prove the Thevenin theorem. Okay, and also here state and prove the Norton's theorem is also there. Okay, state and prove Thevenin, state and prove Norton's theorem, and state and prove what do you say here superposition theorem and also reciprocity theorem. కాబట్టి 4 క్వశ్చన్ నుంచి ఖచ్చితంగా they are going to be asking as a essay question. Okay, you can go for that. Superposition or reciprocity, Thevenin or Norton. Okay, out of these four, you may expect one essay question from this. Okay, that's it. So by coming class, that means by tomorrow's class, we will discuss about the here magnetostatics, block 3. Okay, so in this also 3 units are there. Ampere's law, what is Ampere's law, what is Biot's law, what is a magnetic field and magnetic force on a circuit. Okay, so this we can discuss by tomorrow's class, that is in Ampere's law. Okay, right, all the best. So, okay, tomorrow we can discuss about the magnetostatics class. So, in that magnetostatics, what is Ampere's law? What is Biot-Savart's law? So, in previous conditions, we have been discussed about the electric field portion, and there only we have been calculated that what is electric field capital E value, that is related to the entire electric field, electric potential, uh, sources, network theorem, like that, all these. So by this is the another portion we have to discuss with the magnetic fields. Okay. So B values. In previous conditions, we have been calculated the capital E values, electric field values, and magnetostatics, that is related to the here magnetic field value. You have to calculate the capital B values. In electrostatics, capital E value have been calculated. In magnetostatics, you have to calculate the magnetic field capital B values by implementing the different laws, and also there also you have to implement the such equity applications. There you have to calculate the capital B values. So we will discuss tomorrow's class in with respect to the B values. Okay, right, all the best.